is f positive, negative, interval for f prime? When is it positive, negative? What does it mean? What does that tell you when you know when f prime is positive or negative? What questions does that answer?
Whether the slope is positive or negative.
Just both positive or negative, so that relates to increasing, decreasing. We asked, when is it increasing, when is it decreasing? You definitely need to normalize. There's one other time you need to normalize the f prime. What's that? Actually, yeah.
When making the actual graph.
Yeah, okay, first sketching. First sketching, you have to know increasing, decreasing, and then draw a graph. So you get to normalize for that. There's one other thing that's kind of hidden that you need a normalize. That is the first derivative test. If we say use the first derivative test to decide if this is a relative max or min, you have to draw a normalize. Because the first derivative test is saying you go from increasing to decreasing. Well, for a max, how do you know if you go increasing to decreasing? You then need number line because anything increasing, decreasing is based on number line. What about second derivatives? When do we actually need number lines for that? Besides curve sketching. Curve sketching, we need number lines. We graph by drawing or finding number lines.
The second derivative test?
That would be a great test to draw.
Like, are you saying do we need the...
Oh yeah, do we need a number line for the second derivative test?
No.
No. That is always something to keep in mind. Sorry, I might have. Yeah. So second derivative test, we don't need number line. Why not?
Because you use that to determine whether it's a relative.
It's still asking about relative max min, which is still asking about behavior really of f prime, right? Do I go increasing to decreasing? So the second derivative test says, at my critical point, my derivative is 0. So that means it's either going to be like this, or we know it levels off. So what does the second derivative test say? If you level off and you're bending downwards, it must be a max. That means I only need to know is my second derivative positive or negative there. I only need to know it at that one value. I don't care about all these other values. The number line is checking all values at once. Second derivative test says just plug in the critical point and see what happens. It's one evaluation. So if I want to know what are the intervals of concave up, concave down, then I need a number line. So anytime you ask for intervals, that means number line. Technically, to find inflection points, you also need a number line. Why is that?
You need to know if it's constant.
Does the second derivative change from positive to negative or negative to positive? So that's again saying, like I have an interval on the left and right, did it change when it crossed over? Alright, so always keep in mind when you actually need intervals or not. The hardest thing about the test is answering the problem that's given. It's tempting to do a bunch of work that you don't actually need. And then if you start doing that, it's easy to not finish the test. Right? Especially for the word problems like we had today. There might be a problem that says set up, don't solve. Find the objective function, find the feasible domain, nothing else. If you start then taking derivatives, finding critical points, trying to decide max or min, there's going to be a lot of work that you don't need to do. Okay? So make sure you always really read the directions and know which question you're asking or answering. And then when you're studying, what you want to say is, when I read this question, what kind of work do I need? So that you're not tempted to do other work. Because a lot of these concepts kind of build off each other or blend together. Right? So always keep in mind what work is actually needed. Like, ask that before you start doing work. And then when you're circling your answer, go back and reread the problem. Make sure you answer the question that's asked. It's easy to, since a lot of these look similar, it's easy to actually do something else, which is what we're trying to avoid. All right. The other one would be, that kind of talks about most of the sections. The other one is L'Hopital's rule. It's a very random section in 3.6. Hopefully you got a little more practice with curve sketching because you needed limits. So that's one that's kind of been used a little bit more in 3.2, 3.3. Technically 3.4 when you're checking limits for max min, you might have used it. definitely review love couch rule. And one of the things that came up like on the quiz, there are times you don't use love couch rule. That is part of understanding the concept. Okay? So definitely look back at that. In some sense, this is the least number of sections we ever have on a test. But then it's also in some ways the most content because it builds on chapters 1 and 2 entirely. The good news is on Monday when we start chapter 4, we actually take a step back and do something very different for a little while. Which means it's not directly building. Chapter 3 is very much taking chapters 1 and 2 and combining them to solve other problems. Alright. So I wanted to go over the quiz real quickly. I won't be able to post solutions till sometime tomorrow because I have to do a makeup. So I did want to talk about the quiz. Or look at that. The solutions for the other 2 quizzes are already posted. We'll talk about those too. So how do we solve number 1? We want to find the absolute max min. How do we find absolute max min?
You have to find, well, first you need the first derivative, and then you have to find the critical points, and then...
Yeah. So the goal is, for absolute max min, I always want to keep this one in mind. I don't need number lines. What do I do instead? I want to know what's the biggest y coordinate and the smallest y coordinate. How do you get y coordinates? You just plug into the function, right? So then the question becomes, what values do I need to plug in to decide what's the biggest and smallest? Which ones are relevant? The endpoints, critical numbers, and then what else? This was also in this question that's a little misleading. Any discontinuity. Why do we need to look at discontinuities? Is a discontinuity a critical point? Not necessarily, right? So usually I find those, most functions we give you are continuous on their domain. So if you notice in all my solutions, I almost always start with the domain. What's the domain here? 1 over x squared. Can't divide by 0, right? So even though I say on the interval -1 to 2, I still can't plug in x equals 0. So really when I think about what is the max or min here, I'm on the interval -1 to 0, union 0 to 2. So one way to think about it is find the max and min on this interval, find the max and min on this interval, and then see how they compare. All right. If you want to break it into multiple steps. When you have a discontinuity, it really just means take your interval and break it up. And now I can treat it like the same problem, but here and here. So if I try to find critical numbers, the second derivative or first derivative is this. This is never equal to 0, right? So what does that mean? Technically it is undefined. When is it undefined? So my first derivative is -2 over x cubed. Top's never equal to 0. This is never equal to 0. It's undefined if I plug in x equals 0. Is that relevant? Oh yeah, I guess so. Is that a critical number at x equals 0? No. Why not?
So it's not the domain.
Critical numbers have to be in the domain. So the other reason I find the domain is to know my critical numbers. Alright, so I have no critical numbers. So what does that mean to do? How do I find absolute maxes and mins? I plug in endpoints, I plug in critical numbers, and I look at discontinuities. So if I plug in my endpoints, -1, I get 1. When I plug in 2, I get 1/4. I have no critical numbers to plug in. That just leaves my discontinuity. How do we handle discontinuities? What was the definition of continuous? That's way too long. The limit value is the same as the function value. It's actually a little bit of a hint of what to do. I'm trying to find function values, right? If I'm discontinuous, that means the limit value might be doing something correct. So, what do I do with discontinuities? I find limits. I want to find the limit as x goes to 0. Technically, I can do 0 left and 0 right when I said break it into 2 intervals. Here, I don't need to because what's the limit of 1 over x squared? If I plug in 0 from the left or 0 from the right and I square it, It acts like 0 plus. So this limit must be infinity. Did I do L'Hopital's rule for this? No, because it wasn't infinity over infinity or 0 divided by 0. Alright, so what happens here? I have a limit, it's infinity. Can I plug in x equals 0? Like the only way to get to this infinity is by limit, right? There's no x coordinate, I can't plug in x equals 0 and say this is my y value up here. So what are my conclusions? I have 3 numbers. My biggest one is infinity. My smallest one is 1/4.
The smallest one is your minimum, and if you don't have a maximum.
Yep. Smallest one is the minimum. Because the biggest value here corresponds to a limit, I don't actually get there because it's discontinuous. So I throw that one out. So I have no maximum. All right. How long that is that going to work? So my minimum is 1/4. It happens at x equal to 2, and I have no maximum value. And a lot of these you can kind of check if you just sketch the graph. 1 over x squared would have this shape. Does it make sense? Does my answer make sense? This would be the smallest value on my interval. There is no biggest value. Any questions on that one? It's always easier when I do it. Glad this one's on a quiz. I don't want to run a test unless you've seen it before. Anything with discontinuities where it has to go through this more involved argument. I mean, I say more involved, it's still not a lot of work, right? Anything with discontinuities, the function's not going to be awful. So if I have a problem like this on the test where you have to be careful because of some vertical asymptote or something, it'll be like 1 over x squared. It's not going to be something crazy. Good. All right, what about this one? Our goal is to maximize the area. So my objective should be the area. What's the area? X times y. And then my constraint would be how much fencing I have. It says they have 1,200 feet of fencing. So that gives me a constraint. My constraint would be 1,200 is I have 2 sides of length x and 5 sides of length y. So if I add them all together, that must be 1,200. Why do I need that constraint?
You can replace value function.
Yeah, I need the constraint because my area is x times y. I can't find critical numbers or anything, right? I have an x value and a y value. I have 2 different variables. We don't know how to deal with that yet. You can do calculus with multivariate or more than 1 variable. We cover that in Calc C. So if you're curious, we can do this, but it's a Calc C technique. That's something to look forward to if you want to. All right. So what do? Instead, I can like solve this for y. And now plug that in here, and now I have a function of just x's. So now that's only a function of x's. I want to find the maximum of this function. And I could talk about the interval. What would the interval be? I need x and y bigger than 0. If y is bigger than 0, then x must be less than or equal to 600. Does that one make sense? If this side is length 600 and this side is length 600, do I have any more fencing? I only had 1,200 feet of fencing. That means I can't build y at all. So the upper bound is definitely this. If I go above 600, there is nothing left for y. Y would have to have a negative length, which definitely doesn't make sense. All right, so I have my function for area. I have my interval. My goal is to maximize this on this interval. If I ask for a setup, don't solve, you box that and move on. All right. So then, how do I find the maximum? Find the critical numbers. What's my critical number? If I take the derivative, so it's equal to 0, I get x equal to 300. And then my endpoints are 0 and 600. I could plug in a of 0, a of 300, a of 600. 2 of these give me 0. If I plug in 300, I get a positive number, that must be the maximum, so it checks out. Another way that you see this problem solved sometimes is my second derivative is always negative no matter what, which means I always have this shape, which means this critical number must actually be the absolute max. It's a relative max and an absolute max. And it's because my graph never turned around. So I kind of mentioned this in passing. It's a little more, let me just keep the videos on the videos anymore. But because we do curve sketching, if you know this curve has this shape, you also know is it an absolute max or min. So that's kind of combining an idea from 3-3. In 3-4, we can always just set up like plug in and find out what happens. All right. And then what answer do I circle? I know the area is 36,000 square feet.
That's where the.
Yeah. What's the last thing? Go back to the question and see what it's asking. The question said what dimension? So my final answer would be x must be 300. And then if x is 300, y must be 12 or 120. Where does that come from? If I know x, I know y. So you have to go back up here and plug in. All right. Any questions on that one? All right. So we did have the old quizzes. So just I wanted to mention. I think most people got this problem right. I noticed in the homework people weren't writing the intervals. They draw the number line and stop. But it says what are the intervals, you also need to mention what are the intervals. Alright, so again, make sure you answer the actual question. This problem, there were a couple common mistakes that I did want to mention out loud. A lot of people drew this point as a 0 right here. Why would I count off a little bit for that? I didn't count off much, but why would that not be correct?
It would have listed the x-intercept on the.
Yeah, that first number line says f must be positive if I'm less than 1. So can I put a 0 here? F must be a positive number, I need to move that point up. And then, why would it not be right to have a vertical asymptote here? Yeah, so it says the derivative doesn't exist, but what does that first number line say? If I plug in x equals 0, what do I get?
Positive number.
A positive number. So can I draw a vertical asymptote? No, I need a positive number here. So you just put some point here on the y-axis. And then why does my derivative not exist?
It's continuous but not differentiable.
I have to glue together this shape where it's curving up and this shape where it's curving down. So that's going to give me a point here or some corner type shape. Or a cusp, I can do either one. But there's going to be something here where it's like a corner, so I can't have derivative. Alright, so those are kind of the more subtle ones I wanted to mention out loud, where you might have lost it a little bit. I wasn't taking off huge credit for that. The other common mistake that's easy to do, you glue together this and this. What changed from here to here?
Here we can positive and negative.
Yeah, my graph goes positive, negative. Did anything change with the derivatives? No, so really that says keep the same shape and just cross the x-axis. Alright, the common mistake was doing something like this. Where it's like you draw this shape and you draw this shape instead of treating it as one big piece. But then what would that mean here for the derivative? The derivative wouldn't exist because it doesn't have a corner. So you have to be careful on stuff like that. Right. So always, the hint there would be after you draw the graph, look back at the number line, see if it's consistent. If you can check that more closely, right? I have this shape. Does it make sense? So when is it positive? I'm positive as long as I'm less than 1, check mark. Right? So these, it's hard to come up with the picture, but it actually is pretty fast to check it. When am I concave up? Always. Well, that's concave up. That's bending upwards. That one checks. It's like once you have the graph, you can see it faster. All right. So that's another way not to lose some of those points. Last one, I guess, on quiz 6. A lot of people might need your calculator. E to the 0 is 1. Cosine of 0 is 1. You get 0 to 1, you do look down the rule or anything? No. That was the one that was to make sure you know not to use locality. The flaw is when people say e to 0 is 0. Now it looks like locality rule. So if you miss something like that by a simple evaluation, definitely bring a calculator. Those are things. Some of those, it's easy to write 0 or 1. Same thing happened on part A where people would get non-indeterminate forms. If you're making those simple ones where you plug in 0 and you get either a 1 or a 0 or something that you shouldn't plug in, make sure you have your calculator. You can double check these. Okay. Because the problem is once you have the wrong form, all your work changes. Like all locale rule, everything assumes this first time you plug it in, you get the right form. So any typo there can really go the wrong direction very quickly. Right. And then this last one, there is the e to the natural log trick. My guess is something on the test will be like that, kind of like the test show. But there's usually 1. So definitely make sure you look back at this. Alright, I guess, yeah.
So we should expect straight up locale problems?
Most of it will be a fraction, so you can use locales, or it'll be a fraction that's not the right form, so you don't use locales to get the answer.
Okay.
But then there could be one that's 1 to the infinity, something like that, or 0 times infinity, where you have to move something. There will be one where you have to manipulate it. So usually, like when there's 3 questions, there's typically one where it doesn't apply, and typically one we have to manipulate. And then one that's a little more straightforward, like this first one. If I had 3 questions, those are kind of the 3 cases to think about. But then there's lots of examples for each case, which is what makes the test fun. I shouldn't say fun.
Ready?
All right. Guess I'll see y'all Friday. Hey, you only have to study. You've already